Hi, everybody. Since so many people have had questions about electron configurations and orbital diagrams, I figured I would make a video using this chart right here to hopefully help you guys with this process. So first off, I want to point out on the edge here, we have energy levels. That's what that E stands for. It's also is the N, or the energy level represented in a particular question about an electron configuration. Up here, we have the subshell electrons capacity. Now, this one right here represents the S subshell. These three columns right here represent the P subshell, and the 5 columns right here represent the D subshell. And last but not least, the 7 columns over here represent the F subshell. And these numbers right here indicate the number of electrons, or the electron capacity, in each of these subshells. Each of these lines here represents an orbital, and an orbital can hold up to 2 electrons. So let's say we have a question about the electron configuration of, let's just choose the element nitrogen, for example. So nitrogen has a periodic table, is on the periodic table. It has atomic number 7. So that means that it has 7 electrons. So if we want to write out the electron configuration for nitrogen, I'm going to start here with the very first floor of my building, so to speak. This is the first floor, and this is the S room that can fit 2 electrons. That's why I've got 2 arrows going in opposite directions here. So this is my orbital diagram, and then I'm going to write out my electron configuration. So I'm going to put 1 to show that we're on the first floor. I'm going to put an S to show that we're in the S room. And then I'm going to put a little 2 to show that we have 2 electrons there. Now, we've got 2 electrons, but we need 5 more. So that means that the next electron is going to have to go in the second, going to go up to the second floor and go to the S room first because it's a little bit closer, at least a little bit easier to get to than the P rooms down here. And even though electrons would prefer to be by themselves, they would rather double up and share an orbital before they move up to a higher energy level or a higher energy sublevel or subshell. So we've got 2 electrons on our second floor in our second floor S room. So 2 electrons there. So now we have 1, 2, 3, 4 electrons. We've got to have 3 more to account for all of our 7. So we're going to go up to the next surface area. We're going to go to this surface area, and I'm going to put in 1, 2, 3. Now, why did I put them all in separate orbitals? Well, because in the P block of rooms, there are 3 different orbitals or rooms, so to speak, and each of those orbitals can fit 2 electrons. Now, if they can get their own orbital without having to go up to a higher energy level, then they'll do that. So these electrons are lucky in the fact that they just end up with their um, with their own orbital, so to speak. So now notice we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 electrons. So for this, I'm going to finish out writing our complete electron configuration. Notice how all these small numbers up here in the corners how they all add up to a 7. 2 plus 2, 4 plus 3, 7. So all of our electrons are accounted for, and we've got 2 electrons on our first floor S room, 2 electrons on our second floor S room, and we've got 3 electrons in each of our P rooms on the second floor.